Alright guys, we are solving 2022's paper 1, which is the theory paper. And as always, you're going to fill in your name right here. So whatever your name is, for example, I'll say and a little less thicker. Abu Mohammed. Okay, and you can leave the other names blank. You can enter whatever center number you have. Okay, and what is your candidate number? 4. Right, you don't need to fill in these places. This is not for you to fill. Okay, so the total marks for this paper is 80, and you'll see how we solve this, inshallah, and you'll get to know how you can fill in the answers as well. So question number 1 says, some questions must be answered with a cross in a box. Change your mind about any answer, put a line through the box, and then mark your answer with a cross. Okay. Let me take my brush size down a little bit so I can write a little better. So the first question says, computer systems have both hardware and software components. Central processing unit CPU uses the fetch, decode, execute cycle. State what is meant by the term program instruction. That's the first part. And always notice the marks that we have. 1 mark. We're going to spend that much time on this question. Part 2 says, state what is meant by the term memory address. Okay, again, that is also a 1-point question. I will look at this part B later. So right now, if you can answer this question, inshallah, what you'll have to do is you'll have to pause the video. So right now you can pause the video, solve this question yourself, and then play the video again to see how I solve it and what the answer is. So the way you would answer this, state what is meant by the term program instruction, is what is basically a program instruction? It is you giving an instruction to a computer to do something, okay? To carry out an action, an operation that will be executed by the computer. And the computer is basically that you can say that this is the CPU, or you can also call it the processor. So what we can say here is, I'm just going to say it in a way that obviously your words can be different. So an action or task that will be executed, spell that correctly, executed by, you can say it in multiple ways. You can say CPU, you can say the processor. Okay. So an action task that will be executed by the CPU or the processor. You could also say an action that is executed by the CPU or processor. Okay, I'm going to share the answer with you here and the mark scheme for this question, so you can take note of this as well. This is how you will score on this question. So I'm going to put that right here. as you can see, it says an action task that is carried out by the CPU. You can say this will give you 1 mark. You can also say an operation code that is or will be executed by the CPU. That's 1 mark. And something that tells the CPU processor device what to do. All of these give you 1 mark. And they also would allow examples. So instead of saying, or if you don't remember how to answer this, you could always also just give an example of what a program instruction is. For example, you could tell the computer to print something. Okay, so you can give that as an example. All right, let's move on from here. Now, the second question is state what is meant by the term memory address. So again, I ask you to pause the video, come back to see the answer. So it says state what is meant by the term memory address. Okay, my pen's gone big again. Turned white. Make it black again. There we go. Okay, so what is meant by memory address? We are going to answer that now. Yeah. This is here, memory address. What is memory address again? Basically, memory address refers to the reference, or it's pointing to the place in memory. So for example, we have memory right here. We have memory right here. And there are slots in this memory. So each slot would have an address, okay, an address. So when we say memory address, we're basically saying we're going to store some memory here. For example, we store the string hello in here. Let me fill that in actually. So we are going to store the string hello in here. Okay, let's say that's what we stored in here. Now, hello is the content. Address would be the location in which this memory is stored. Let's say this is location number 001. Okay, let's just say that. So this is going to be the memory address. Now the address could be a byte, okay, and this is what we're referring to. So basically the memory address is the reference to that item, that data stored in that memory. Okay, so we are going to put that as the definition here. So this is a pointer to the location of the data I'm actually going to remove all of this. Okay. Location of the data stored in, let's say, stored in the memory. Okay, that's one of the valid answers that you can give to this question. And now let me share the mark scheme answers with you. Here are the marked answers that you can look at. You can see a pointer reference, pointer, you can say a pointer or reference to or identification of a location in memory. That will give you the 1 mark that you need here. So say a pointer reference to location where data will be accessed from or stored in or stored to. Okay, so take a note of that, and this is how you can answer this question as well. Next, we have the question which says, identify the component of the CPU that provides temporary data storage. So, which do you think this is? Pause the video. Come back to the answer. Right. Whoa. So here we're going to say, the answer is actually identify the component of the CPU that provides temporary data storage. So address bus, data bus, these are buses. They are basically wires. They are not storage devices. Control unit is like a manager. Okay? It makes decisions, but it doesn't store any data. So the only option here is register. So we're going to make a cross on register right here. And make crosses the way I've done right here for the multiple choice questions like this. Alright, let's move on. Then we have question right here. It says the performance of the CPU is affected by the clock speed. Give one benefit of having a higher clock speed, and then give one drawback of having a higher clock speed. So go ahead, pause the video, come back to the answer. Okay, so one benefit of having a higher clock speed is that you can run more instructions. You can run more instructions. You can run more instructions per second. Well, actually, I should rewrite that saying you're not running the instructions, right? So we can say more instructions can be carried out. A little trouble writing with this pen. Can be carried out per second by the processor, by the CPU, or you can just leave that out. Okay, that's one way to answer this. The other drawback that you can have here is one of the major drawbacks is it could cause overheating. This is one of the major things that you can always write for this. It could cause, apologies if my handwriting goes bad, I'm kind of struggling with my pen here. It could cause overheating. Starts acting wonky all of a sudden, my pen. Okay, so it could cause overheating. Right, so like always, I'm going to share the mark scheme question for this question as well. So you can see all of the different kinds of answers that you could have given for these two parts and scored the points, inshallah. So for benefits, you can say it can, for benefits of higher clock speeds, more instructions can be carried out per second, processes will run faster, programs are executed faster, you can run more complex programs. For example, you can run games that weren't able to run before. You'd be able to process games better. It will behave like your processor is now a higher end processor. Obviously, then the drawbacks are that the CPU computer could overheat. We already wrote that one. More cooling would be required. That's another drawback. It needs more power, or the CPU could become unstable, crash, or its lifespan could be shortened. These are all ways that you can score for this question as well. All right, let's move on to the next question, which is on the next page. So this is in multiple choice question again. It says identify which one of these describes a sequential computational model. The options are in front of you. What is a sequential computational model? So if you remember, we talked about different kinds of computational models. Well, I'll leave this answer for you to firstly solve, look at the options, and try to answer them. Pause the video, come back for the answer. So the answer here is pretty simple. Firstly, you're going to read through the instructions. Which one is a sequential computational model? So firstly, we see program instructions are read one after another from external storage. So we can't really say that it is being read from external storage or accessing data from secondary storage. That's not going to be right because we didn't learn about anything like that, and this definition is kind of irrelevant, okay? Program instructions are executed by multiple agents working together. Multiple agents working together. No, that's not sequential. That doesn't sound like sequential to me because this is actually describing the multi-agent computational model, sorry. Then we have program instructions are executed in parallel by different cores. This is describing the parallel computational model. Program instructions are executed one after another. Yeah, that sounds like sequential. So D is definitely the answer right here. Let's move on. It says a program can be written in a high-level or low-level language. Give one reason for writing a program in a low-level language. Why would you write a program in a low-level language? Then the other question here is state the purpose of an assembler. I think we'll do that after this one. So part one, feel free to pause the video and solve it on your own and then come back for the answer. Okay, so I'm actually gonna use the type tool right now because I'm having some trouble writing with the pen. So I'll use the type tool. Obviously, you guys are gonna write in the exam with a your pen, obviously a black ballpoint pen. So I'm going to utilize the computer's typing tool, and let's do this inshallah. So give one reason for writing a program in a low-level language. Guys, why would we write programs in a low-level language? Firstly, we want to make sure that we have more control on the program. And so again, the difference between a high-level or a low-level programming language, we have to remember that what is Python? Python is basically a high-level programming language. It is not a low-level language. Examples of low-level languages are assembly languages, okay? And you don't say things like print statements and everything. Now, when you talk about low-level languages, you're actually working at the register level, at the memory address level. Okay, so you are like we saw how assembly languages work. We say add something to this register, move the contents of this register to this register, add the contents of these two registers together. So we saw and compare the values between two registers. So we're working at that level. Okay, so assembly language code, assembly language programming is an example of low-level languages. So this is what we're talking about here. We're not talking about Python or anything like that. So be careful. Python is high-level programming language. Java, C#, all of these are high-level programming languages. So they're essentially asking you about assembly language. So why would we write an assembly language? Again, you guys know assembly language because you guys took my course. Assembly languages are used when you have limited, for example, you're using a very limited kind of hardware. It doesn't have a lot of memory, doesn't have a lot of like processing power and all that. It has limited hardware. This is a good use. This is a good reason why you would use a low-level programming language right here. Uh, so you can say when fast execution of the program is essential. So low-level languages give even faster. They reduce the file size, the storage. If storage is an issue, they can reduce the file size of the program that is to run as well. We talked about a game that was, I forget the name of the game, but we talked about a game that was just 22 kbs in space, and it had 3D models. It had all of those. It had a lot of information in it, but because it was coded in assembly language, uh, it was um, it was really tiny in size, just 22 kbs. So that's the idea. That's the idea that we want to put down here on in one sentence, because remember it's a 1-point question, so we are going to answer it accordingly. So we could say here, when there is limited space, limited hardware or memory for storage, um, we can um, use assembly languages, or we could just say we can use we should use well, we don't need to say anything more. So when there's limited hardware or memory for storage, okay, you can mention that. Um, this is going to be enough for you to get a point on this question. So again, I'm going to share the mark scheme with you. And you'll see for this question, it says award 1 mark for example, when fast execution of the program is essential, or this gives faster execution. So we're talking about faster execution of the program. Okay, when writing code to control a device or directly access the hardware. Right, so this gives us more. So again, there's no operating system in the middle. A low-level programming language is working directly with the hardware. There is no OS layer in the middle. Okay, unlike with higher level programming languages, there's an OS layer in the middle, and the higher level programming language such as Python, it doesn't work directly with the hardware. Rather, it works with the OS, and the OS works with the hardware. So in a low-level programming language, you are working directly with the hardware. To make efficient use of a device's limited storage, memory power. So this is something that we answered. Okay, when writing code for a particular architecture hardware embedded system. So maybe this is a very limited kind of hardware that doesn't have a operating system on it, and it's just hardware. It's a different kind of hardware, and you have to write a special kind of low-level programming language for working with this for making it work for you. Okay, the next question is state the purpose of an assembler. Pause the video and come back for the answer. So the purpose of an assembler very simply is to um, so what we can say here is to translate machine code, to translate assembly language. We could also say to translate or convert, because remember, assemblers are basically translators. To translate or convert, you can use either of the words, an assembly language into machine code, or you can say machine, you could also say object code. Remember object code? So machine code or object code. So that should give you the point. And this is the perfect answer for this question. It says complete the table by adding one tick in each row to match the description. Okay, so there's some descriptions written on the left, and then we have some columns for compiler and interpreter. We have to add a tick for whatever description fits compiler or interpreter. So this is a 3-point question. So you have to make sure that you get all of these correct. Okay, but if you get just any 2 rows correct here, you would get 1 mark. If you would get 4 rows correct, you would get 2 marks, and if you get all 5 correct rows, then you would get 3 marks for this particular question. So I share that with you so you can know how they mark your question, okay? But while you're doing the exam, don't think about all of these things. Just try to answer as much as you can and don't spend too much time. Try to do it as quickly as possible. Okay, so let's read again, pause the video, come back to see the answer. Right. So translates the program each time it is executed. This sounds definitely like an interpreter. So I'm going to constantly fill in right here. This is definitely sounding like an interpreter. This produces permanent object code. What do you think produces permanent object code? Right? That sounds like a compiler because it goes over all of the programming code once. Okay, it converts it into object code or machine code, and that's the permanent file, right? So that's what the compiler does. This is definitely the compiler. Translates line by line. This is definitely the interpreter. Makes sense. Translates the whole program before it is run. Definitely compiler. That's what the compiler does. Generates a list of errors once the complete program has been translated. Also, definitely the compiler. Not a very hard thing to answer, inshallah. I hope you guys get how to solve this. All right, let's move on. So here we have the question that says computers use binary to represent and store data. So these are some questions from Unit 3 where we work with binary conversions to denary, hexadecimal, and everything. So it says the denary number 78 is the ASCII code for the character n. Convert the denary number 78 to 8-bit binary. So the information they give you on top right here is not really necessary to know. That's just some information they shared with you. Not really relevant for you to know this in order to answer the question. The actual question is convert the denary number 78 to 8-bit binary. Right? So it's just a simple denary to binary conversion. So we're going to start with the answer. And I'm going to pull out my pen for this one at least, inshallah. So we're going to try and do this as neatly as possible here. Okay, so firstly, we need to remember our place values if we want to solve this. Okay, so we are going to put down our place values. I'm going to say, I'm going to try and draw a column here. So I can start here. So I'll say 1, 1, 2, 4, 8, 16, 32, 64, and 128. These are my 8 bits, place values for my 8 bits. Now, I'm going to start filling in for 78. So remember, when we convert from denary to binary, we're going to ask ourselves the question, is 78 greater than or equal to 128? It is not greater than, it is not equal to 128, so we're going to put a 0 here. Then we're going to move on to the next place value, 64. Is 78 greater than 64? Yes, it is, so we're going to use this. We're going to put a 1 here. So now we need to subtract 78 and 4. So we can do that on this side. Let's draw another column here. And let's say rough work. Okay. And then we can say, so here we can do our calculation. 78 minus 64. So we subtract the 8, the 4 from the 8. We're going to get 4 here. And we're going to subtract the 6 from the 7. We're going to get a 1 here. So the remainder is 14. Now we want to ask ourselves, while looking at this remainder, what is the next question? What is the next place value? 32. Is 14 greater than or equal to 32? No, it is not, so we're not going to use that. Then we're asking ourselves the question for 16. Is 14 greater than or equal to 16? No, it is not. It is not greater to. It is not greater than. It is not equal to. It is definitely greater than 8, so we are going to use 8. And then we're going to subtract 8 from here. Move this line that I just made here. Sorry about that. Okay, so we're going to subtract the 8 from here. We can't subtract 4. We can't subtract 8 from a smaller number that is 4. So we're going to have to carry the value from here, bring it over here. This is going to become 14. Well, now we can do it. So we can say 14 divided minus 8 is going to be 6. Okay, so now we have 6. Let's go further over here. So 6 is definitely greater than 4. We're going to use the 4 value as well. So I'm going to start from here. We're going to say 6 minus 4. Okay, 6 minus 4. And 6 minus 4 is 2. Okay, sorry. Why is that anchor showing up there? Okay, 6 minus 4 is 2. So 2 is definitely equal to 2. So we're going to take the 2 over here. And now 2 minus 2 is always 0. So we don't need to go on any further. And we can just say we've used all the values. We have our number now. So if you were to just add these numbers together, 64 plus 8 plus 4 plus 2, and I'll do that on the calculator just for verifications. Obviously, you're not going to need to do this on your computer, while you're doing the exam. This is just for your satisfaction. That's 64 plus 8 plus 4 plus 2 is equal to 78 in 8-bit binary. So this is going to be your answer. Okay, you're going to say 0, 1, 0, 0, 1, 1, 1, 0 is the answer. You can draw like a box around it and you can say answer. Also, one more thing I wanted to add here is no matter how many leading zeros you add here, these are known as leading zeros. No matter how many leading zeros you add is not going to affect the answer. So it is not going to affect the answer. Your answer is still going to be correct as long as you have the 8 bits done correctly, 0, 1, 0, 0, 1, 1, 1, 0. Okay, obviously you don't need to add these leading zeros. If you did, for some reason, that wouldn't make the answer wrong. No matter how many zeros you add here in the start of your binary number, it's not going to affect the answer. Okay, so yeah. Let's move on from here. It says identify the number of characters that can be represented using standard ASCII. Okay, so pause the video, come back for the answer. Yeah. So it says identify the number of characters that can be represented using standard ASCII. So I want you to focus on this word standard, okay? So we learned that there were different forms of ASCII before we came to the format that we have today, the 8-bit ASCII. Before the 8-bit ASCII, we had the 7-bit ASCII. Okay, and this was known as the standard ASCII code. So we again started with 7-bit ASCII in the beginning, okay? And 7-bit ASCII basically means that we had 7 bits to represent, so base 2, power 7. That means we have 7 bits to represent information. So basically, if you have a number that has 1, 2, 4, 8, 16, 32, 64, 128. How many bits are these? This is starting from 2 raised to the power 0, 2 raised to the power 1, 2, 3, 4, 5, 6, and 7. Okay. How many total bits are these? This is 1 bit, 2 bit, 3 bit, 4 bit, 5th bit, 6th bit, and 7th bit. And this is the 8th bit. So when we say 7-bit ASCII code, we're just utilizing the 7 bits of the byte. And so that would mean that if you're representing the characters, for example, the letters, the lowercase letters, the uppercase letters, you are just utilizing only the 7 bits till here. But before the extended ASCII code came out, so again, remember there are 2 kinds of ASCII codes. One is the standard, and the other, after that, the standard was 7 bits, and the 7 bits was equal to 1. Let me write that down here actually. So let me write that down here. Standard and a better place to write this. I'll write it right here. So standard, the standard ASCII had 7 bits, which is equal to 128 characters. It could represent 128 characters. Okay, and you can see that if you add all of these up, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you would get 128. If you don't believe me, let me open up the calculator. So if I add all those numbers up, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, I get 127. Oh, so we get 127. 127 again because we are representing the last number. But if you include 0, this would be 128. Okay, we count the 0 as well. So we have a total of 128 characters that we can represent in standard ASCII. But the problem with this was that, so for example, if a character was represented like this, let's say 1110000, let's just say that this meant the letter A. Okay, this meant the letter A. The 8th bit was never being utilized, which was 0. It was left as 0, and this blast, because the byte had 8 bits, you had to fill all 8 boxes with values, but they only needed 7 bits in the standard ASCII when it first came out, and this first came out in the year in the 1960s. Okay, then after that they realized, some people said, why are we not utilizing this last 8th bit right here? We can use this last 8th bit and represent even more characters, right? So then they started utilizing, let me change the color of the pen. They started utilizing the last 8th bit here as well. The last 8 bits started being used again, and this then started being called the, so now this is then called the extended ASCII code. It's the extended ASCII code, which is 8 bits, and it is equal to 256 characters that can be represented, okay? Starting with 0. So in this question, they're asking us about the standard ASCII code. So we definitely need to highlight the standard ASCII code. This is not the extended ASCII code. The standard ASCII code is 128. So the correct answer is B. So I know you might be enticed to just put 256 here, but you're going to lose a mark if you answer this incorrectly. So they just wanted to test if you know the difference between standard ASCII and extended ASCII. And we covered this in our course when we were doing this. So let's move on.